Welcome to bmac.math tutorial. Subscribe our channel and hit the bell icon for freshly uploaded contents. This is a question from GATE 2020. Here we are given a matrix M 3 cross 3 and we are given two statements and it is asked whether these statements are true or false, satisfying some kind of conditions. So before going to solve this problem, let us convince ourselves with the statements that statement 1 says that there exists a lower triangular matrix L such that M is equal to L into L transpose. And the statement 2 says that the Gauss-Seidel method for mx is equal to b converges for any initial choice x0. Now we know that for any kind of decomposition of a matrix, the given matrix should be a non-singular matrix. Hence, for option 1, the matrix is given by capital M is equal to alpha 3 0, beta 3 1 and 0 1 2. For the decomposition of this matrix into this form M is equal to L transpose, we must have M to be non-singular. That is, determinant of M must be not equal to 0. Now, determinant of M is equal to alpha 3 1 1 2 minus 3 into determinant of beta 1 0 2. This is equal to alpha 6 minus 1 minus 3 into 2 beta. This is equal to 5 alpha minus 6 beta. Thus, if the statement is to be true, then if statement 1 is true, then 5 alpha minus 6b must not equal to 0. Now let us check the option A. Here we are given that the statement 1 is not true when alpha greater than 9 by 2 and beta is equal to 3. Now if beta is equal to 3, then 5 alpha minus 6 beta not equal to 0. This implies alpha not equals to 6 beta by 5, which is equal to 18 by 5, which is equal to 3.6. This implies alpha should not equals to 3.6. Now it is given that alpha is greater than 9.9 by 2 is equal to 4.5. Therefore, for this for the values of alpha which are greater than 9 by 2, the statement 1 is true. Thus, when alpha greater than 9 by 2, the statement 1 is true. Hence, option A is false. Now, let us check option B. In option B, we are given that 2, the statement 2 is not true. Statement 2 is not true when alpha greater than 9 by 2 and beta is equal to minus 1. Statement 2, the Gauss-Seidel method for mx is equal to b converges for any initial choice x0. And we know that for Gauss-Seidel method, the matrix must be diagonally dominant. That is, modulus of alpha must be greater or equals to modulus of 3 plus modulus of 0. Modulus of, for second row, modulus of 3 must be greater or equals to modulus of b plus modulus of 1, and for the third row it is automatically satisfied that modulus of 2 greater than equals to modulus of 0 plus modulus of 1. This implies modulus of alpha must be greater or equals to 3. This implies modulus of beta plus 1, modulus of beta plus 1 must be lesser equal to 3. This implies modulus of beta must be lesser equal to 2. Now, in option B, we are given that the statement 2 is not true when alpha is equal to 9 by 2 and beta is equal to minus 1. Now, since beta is equal to minus 1, this implies modulus of beta is equal to 1. Modulus of minus 1 is equal to 1, which is lesser equal to 2. And since alpha is equal to 9 by 2 is equal to 4.5, therefore modulus of alpha is equal to modulus of 4.5 is equal to 4.5, which is greater or equals to 3. Hence, for these values of alpha and beta, the matrix M is diagonally dominant, and hence the statement 2 is true. Thus, statement 2 is true. Hence, option B is false. Now let us check the option C. In option C, we are given that statement 2 is not true when alpha is equal to 4 and beta is equal to 3 by 2. Alpha is equal to 4 and beta is equal to 3 by 2, that is beta is equal to 1.5. অতএব modulus of alpha is equal to 4 and modulus of beta is equal to 1.5, and modulus of alpha is equal to 4. This is greater than 3, and modulus of beta is equal to 1.5, which is lesser equal to 2. Hence, for these values of alpha and beta, the matrix becomes again a diagonally dominant. Hence, statement 2 is true. Thus, option C is false. Now, let us check the option D. In option D, we are given that 1 is true when alpha is equal to 5 and beta is equal to 3. Option 1, alpha is equal to 5 and beta is equal to 3. Now, for the option 1, we must have 5 alpha minus 6 beta not equals to 0. That is, now 5 alpha minus 6 beta is equal to 5 into 5 minus 6 into 3, 25 minus 18 is equal to 7, which is not equal to 0. Hence, 5 alpha minus 6 beta becomes non-zero when alpha is equal to 5 and beta is equal to 3. Thus, the matrix becomes non-singular. Hence, some kind of decomposition is possible and therefore the statement 1 is true. Therefore, option D is true. Thus, our correct option is option D.